Guys, welcome to the channel. This is Waga. We are going to do another Leetcode question, and the question in question is number 132. No, number 456, 132 pattern, right? So we are supposed to get the 132 pattern. In this case, the 132 pattern is where we have a number such that we have an array, right? An array of integers, and we have in the array, the elements, there should be one element which is the minimum, one element which is higher than the minimum, and then one element which is the midpoint, right? So in this case, 1, 2, 3, 4, we should, and then you return true whether or not it's true, right? In this case, we have 1, 2, 3, 4. This is not true, but 3, 1, 4, 2. We have 1, which is the minimum, 4, which is the greatest, and then 2, which is less than that, right? And ideally, they're not supposed to be in order, and we are also supposed to do it in O n log n or O of n, right? Instead of using, you could, if you wanted, use 3 loops, right? The easiest way would just be to use 3 loops, right? Just check that j is greater than I, and then k is lesser than j, right? So basically that. But we are not going to do that. We're going to use, of course, we're going to do and try and sort it out in a better time complexity than using 3 loops, right? So how we could do this is we could come here and the first thing we do is we create a minimum array, right? So we could call it something like min list, right? We say min list, and here what we do is we put in the minimum number, right? So this n is just gotten from the third example. If you can look at the third examples, we have nums there, so we're going to work on this and conceptually have a look at it, and then possibly solve it, right? So what we're looking for here is the value of I, right? Because it's ijk. So I is the first. Let's come here and say I, j, and k. What we're looking for here is the value of I, right? So here we push in the minimum at each element. For each element, it's going to be as long as the nums array, in this case our n array, right? So we could have -1 is 3 greater than -1. No, so we have -1, and we have -1, and we have -1. Okay, 1, 2, 3, 4. Basically that, right? It's supposed to be the same length, right? And we then create a stack, and in our stack, where the stack is going to look for the value of k, right? So we have our stack here, and it's going to look for the value of k, right? And we start off by putting in our first element, in this case 0, and then we loop through our array backwards, right? That's why we're starting with 0, right? So we loop through our array backwards, and at each point we compare the various numbers, right? We compare, we move, for example, we consider k, this number, to be the first candidate for our k, and then we move our array down to 2 in this case, right? So we check, for k, is 0 a possible contender for k? Yes, so 0 is a possible contender for k. Is -1, I is going to be -1 at that position, so we have I in this case is going to be -1, right? And then we move our pointer down to 2, right? Is 2 the highest of those 3? Yes, so we do have j being 2. So in this situation we're supposed to return true, right? So we have our ijk being -1, j being 2, the highest, and k being 0, right? So that's how we would move, and at each point we pop off things on our stack and put them back, right? The satisfying condition is whenever we come to our min list and check that our min list in I is less than the top number in our stack, right? This is our stack, and it's less than nums, the array at I, right? So the top of our stack and whatever is on the array at I. So in such a situation we just return true. So basically that is the idea of what we're trying to do, and now we have to put it in code. The length of nums, of the set of nums, is less than 3, right? If it is, we just need to return false. The reason for this is we need at least 3 elements to have the 1, 3, 2, right? The 1, 3, 2 pattern, right? So basically in such a situation we return false, right? After that we need to create our min list and our stack, right? So we say min list, and this is just going to be an empty array like so. And after that we have our stack, and our stack is just going to be an empty array also like so. And we start off our min list by appending the very first number, and we say min list, and what we want to append is we are going to append the very first number, and that is 0 like so. And after we append that number, we loop through our array, right? And we create our minimum array, right? Aside from just appending the first number, we can create our minimum array, right? And for that we just say for I in let's just spell it correctly, range, and we want to go from the second element because we have put the first element to the rest of the array, and that's len nums like so. And we append the minimum of everything before the current element being looped, right? And for that we just say min list, and what we want to do is we just want to append, and what we are going to append is going to be the minimum in the array of everything before the current element, right? So we just say I like so. So in this situation we have created our min list, and we can continue from there, back of the array, right? And we're going to use the stack to determine the 2 in the 132 pattern. So we check through, right? And for that we could just come here and say, come down here and say for j in range, and the range is going to be the len of nums minus 1 like so. And we want to go backwards, remember, and we want to go all the way to the beginning. So we do that so that it ends before the -1, that is, it goes all the way to 0, right? So that's what the second -1 is for, right? So for that we are going to, remember, we're looking for the 2 in the 132 pattern. We check if nums j is greater than the min list at j, right? And we move to our stack, and we remove everything that is less than the current min, right? So we come here and we say while stack and stack minus 1 is less than, and this is going to be less than or equal to our minimum at that point, right? We just pop it off the stack, right? Remember, we're looking for the 2 in this case on the pattern like so. We check then if the number at the top of the stack is less than j, right? So how we do that is we say if stack, we have to have a stack, and stack is less than j. Remember, it can't be less than or equal, it has to be less than j, right? Because of the 132 pattern. And if that is the case, we just return true because we have hit our goal in this case, right? And at every point we just append nums j, right? So we say stack dot append, and what we want to append is nums j like so. And after all this, what we want to do is we want to return false like so. Over our code quickly. First we create a minimum array, and we append all the values, right? Then we start iterating from the reverse of the array, like over here. That's what we do. And we're going to use the stack to determine the 2 in the 132 pattern, and at all positions we push all elements if they're greater than what is in the minimum array. That is because we're looking for the 2 in the 132 pattern. And then at any position we remove, in this case we pop everything, we remove everything in the stack if it is less than or equal to the minimum, right? Because it's invalid to form the 2 in the 132, right? And the satisfying condition is that the top of the stack is greater than the minimum, and we come across a number at I, which is also which is greater than what is in the stack, right? Because the stack looks for our 2, right? So we get maybe at numzi we get a number that is greater than the stack, the top of our stack, and then it's also greater than the minimum. That's when we form the 132 pattern. So if we run our code and then we submit it, we should get an answer, right? So we run our code and we submit it, and it is accepted. And the time complexity is of course O of n, and the space complexity is also O of n. We create a bunch of structures, and they're going to be as long as our nums array. So thank you for watching. Subscribe to the channel if you're new, and I'll see you in the next video.